Hello all, and welcome back to another Physics 2212 video. This is Lab 4 Circuits. Closing. The purpose of this lab is, as always, to showcase physics principles, to predict the behavior of circuits containing resistors in series and in parallel, and to use multimeters to measure the actual values, components, circuits, and potential differences in the circuit, to compare that to a simulated version, and to examine the behavior of ohmic resistors and capacitors. Principles at stake here, we have energy conservation, or the loop rule, present here. Current conservation, which is a combination of charge conservation plus the definition of steady state. And we use that to define the node rule. Then we have dissipation of energy through resistors and storage of energy through capacitors. Findings are that the node and loop rule hold true. Current in an RC circuit is time dependent, meaning that's exponential, and the current in the first circuit is 0.02 amps, and the RC value of 6.88. Here's the circuit we built in class or in the lab. Here's our visual model, the system being the circuit and the surroundings of everything else. We built the circuit in the lab and then further modeled it in the circuit construction kit through Colorado. Prediction, there's a bunch of different steps here, so I'm just going to run quickly through them. We're supposed to calculate the difference in the currents between the first and second ammeters. So first we're going to find the total resistance of 147 ohms. Then we use Ohm's law to solve for the current, and because they are in series, they're going to have the same current, 0.02 amps. Here's the Colorado FET model that I previously talked about. And then when we add in the voltmeter, what happens to that ammeter? We can see that it's going to read 0 amps because the voltmeter has really high resistance and takes all the current and voltage drop. And that means that the voltmeter has to read the equivalent of the batteries or 3 volts. And now we're going to calculate the voltage across all the components. So we're going to use the loop rule. The sum of all the voltage drops across the circuit should be 0. So we have 2 times the battery. So that would be 3 volts. And then we're going to equate that to the current times the resistance. So we have negative 0.96 volts for this one and negative 2.04 for this one. So when you attach voltmeter, you alter the circuit. So why doesn't the ammeter reading change? Voltmeter has really high resistance, so there's very little current that flows through it. You can see here in the chart of the voltage drop across each component that by the time it gets to the ammeter, the voltage is 0 and it's constant. So now we're going to replace the voltmeter with an ammeter in parallel with the 100 ohm resistor. So what happens to the current through the other ammeter? So the sum is going to be 0 because of the loop rule. We have the ammeter has very high resistance, so current will go through it instead of the 100 ohm resistor. So now all the current is going through the ammeter, which lowers the total resistance of the circuit to 47 ohms. And now we can use Ohm's law again to calculate what the current is, and it's 0.06, so roughly 3 times greater. Now we're going to calculate the resistance of each component from the modeled version. So we're going to divide each voltage drop by the current. And so we got 48 ohms, 102 ohms, and then the wire and ammeter have 0 voltage drop, which means that it's going to be 0 ohms. You can see that these don't quite align. That's mainly due to rounding errors and human mistakes. Okay, now onto RC circuits. We have charging and the discharging of the capacitors. For when you have a 10 ohm resistor, it takes about 10 seconds, and a 20 ohm resistor takes about 20 seconds to charge and discharge. Now, using a 9 volt battery, 200 millifarad capacitor, and 30 ohm bulb, they're connected in series. We're going to try to find the RC value. So we're going to multiply the resistance by the capacitance, which gives us 6 as our predicted RC value. And now using the time and natural log of the voltage divided by the original voltage, we can calculate what the slope of that line is, and then use the inverse of that to calculate the experimental RC value of 6.88 based off the system. Do some discussion questions where we're going to be comparing between our real circuit and our simulated circuit on Colorado FET. And so in the real circuit, the real ammeter has actual resistance to it, which limits the total current of the circuit a little bit, whereas the modeled version assumes that the wires and the ammeters have 0 resistance. Based off of our online simulation, we would assume that without a resistor in the circuit, that the capacitor would charge instantaneously. However, that is not the case, as real batteries and real wires actually have internal resistance. Thank you for watching.